Good morning everyone. Today we are going to learn about 2D pipeline, 3D pipeline, RGB and CMY color model in computer graphics and visualization. First we need to learn 2D pipeline. In a computer graphics and visualization, the 2D pipeline refers to a sequence of stages and processes involved in transforming a two-dimensional objects and scenes into a final rendered image on a display or output device. It encompasses various operations such as modeling, transformation, lateralization, and rendering. Here is an explanation of the key stages of the 2D pipeline. Modeling. The first step in the 2D pipeline is modeling, where the objects or scenes to be rendered or defined and created. This involves specifying geometric primitives such as points, lines, curves, and polygons that represent the shape and structure of the objects. Transformation. In the transformation stage, the object's coordinates and attributes are manipulated to the position, scale, rotate, or otherwise modify them in the desired way. Transformations include translation, rotation, scaling, shearing, and more. Clipping. After the transformations, objects may extend beyond the boundaries of the viewing area or viewport. Clipping is the process of determining which parts of the objects are visible within the viewport and discarding the invisible portions. This prevents rendering unnecessary geometry and optimizes the performance. Lateralization is the process of converting vector-based objects like lines, curves, polygons into a raster image composed of pixels. Each primitive is broken down into fragments or pixels that cover a portion of the primitive areas. The fragments are the processed to determine their attributes such as color, depth, and texture coordinates. Fragment operations. In this stage, various operations are performed on the each fragment to determine its final color and other attributes. These operations include lighting calculations, texture mapping, transparency, blending, and other effective that contributes to the visual appearance of the rendered image. Then coming to the display, finally the processed fragments are mapped onto the display device or output medium. The fragments are combined to form a complete image, taking into account factors such as the depth values, transparency. The resulting image is then displayed on the screen or saved as a file. Here is a simplified diagram illustrating the 2D pipeline. Object word coordinates. First is a clipping, apply window, then object subset, window to viewport mapping, then object screen coordinates, here lateralization, then display. Next, coming to 3D pipelining, this stage involves creating or importing 3D models using modeling software or tools. Models are composed of vertices, edges, and faces which define their shape and structure. Transformation. In this stage, 3D models are transformed to a desired location, orientation, and scale in a virtual 3D space. Common transformations include translation, rotation, and scaling. These transformations are typically represented using matrices. Clipping and quilling. Clipping is the process of removing the objects or parts of objects that fall outside the view frustum, which defines the visible portion of the scene. Culling is the removal of objects or portions of the objects that are not visible due to occlusion or other factors. Then coming to projection, this stage maps the 3D scene onto a 2D plane known as the projection plane or viewport. Common projection techniques include perspective projection and orthographic projection. Raterization is the process of converting the transformed 3D objects into pixels on the screen. Each triangle or polygon is broken down into fragments or pixels that covers its surface. Vertex processing. Vertex processing involves the performing calculations and transformations on individual vertices. The stage can include vertex lightning, vertex blending, and other vertex specific operations. Fragment processing. Fragment processing operates on individual fragments or pixels. It includes operations such as texture mapping, shading, and depth testing. Then, pixel operations. This stage involves additional operations on individual pixels such as blending, filtering, and post-processing effects. Display. Finally, the processed pixels are sent to the display device to be shown on the screen. Here is an example simplified diagram of the 3D pipeline. RGB and CMY color model. Here RGB means red, green, blue color model and CMY means cyan, magenta and yellow color model are two commonly used color models in computer graphics, imaging and printing. RGB color model refers to the RGB color model is an additive color model, meaning that colors are created by adding different amounts of red, green and blue light. In this model, the primary colors are red, green and blue and they can be combined in different intensities to create a wide range of colors. In the RGB model, each color channel is typically represented by an 8-bit value ranging from 0 to 255, where 0 represents no intensity and 255 represents maximum intensity. When all the RGB channels are combined at their maximum intensities, the result is white, and when all the channels are at their minimum intensities, the result is black. By varying the intensities of the three primary colors, different colors can be achieved. For example, mixing red and green light at their maximum intensities creates yellow, while mixing red and blue light creates magenta, and so on. The RGB color model is widely used in electronic displays such as computer monitors, televisions, and digital cameras as they emit light directly. Coming to CMY color model, the CMY color model is a sub-attractive color model used in printing and mixing pigments. In this model, the primary colors are cyan, magenta, and yellow. When combined at full strength, they theoretically absorb all light and produce black. In the practice, additional colors are used to create a more accurate black as the mixing of inks is not perfect. The CMI model works by subtracting or absorbing different amounts of light from white, which is the absence of color. When the three primary colors are combined at full strength, they produce a neutral gray. By varying the amounts of each primary color, different colors can be achieved. For example, mixing cyan and yellow pigments creates a green, while mixing magenta and yellow creates red, and so on. In practical applications such as printing, the CMY model is often combined with a key channel to create the CMYK color model. The K channel represents the key color, which is usually black. Adding the black improves the shadow detail, reduces the amount of ink required, and provides better control over the final printed colors. Overall, RGB color model is primarily used for emitting light, while the CMI color model is used for subtractive mixing of the pigments, especially in printing processes. Thank you.